So how many students are in this class?
Sir,
Sir, more than 100 are there. Uh,
Oh, wow. So have they taken digital design before?
I think, yeah, they have. Pratham can answer it better. Pratham, what are the courses you have taken? And also,
uh,
meanwhile, could you tell your friends to join on the similar course?
yes, I actually messaged them. They might be joining.
Uh-huh.
DSD is a subject, digital system design. So we have completed. I have completed that. Since
Hmm.
this course was in the degree level, so it was necessary to complete DSD. But now it's in diploma level. So the number of students is more is now just because it's there is no prerequisite of DSD of taking electronic testing as measurement. But I also
Hmm.
feel that DSD, computer organization, and digital circuits, they should be necessary to complete.
Yeah, yeah. Without that, it will be tough.
Moreover, I also completed sensors and applications. So in that, we had also covered this precision, accuracy, and all. Uh, the
Okay, good.
multimeter, zero
Ah,
drift, and like that,
yeah.
sensitivity, and all.
Oh, okay, very good. So you have other classes at the same time? I mean, you had another class before this? What is the reason why there are only two students?
Sir, I have messaged it on the discourse also again.
Hmm. Do they have another class before this or something?
Sir, I specifically arranged this time slot by seeing that there is no other live session during this
Hmm.
time.
Uh, Sir, actually, one more thing is means earlier in GSpace we actually communicate with all. We have
Hmm.
not providing the facility of GSpace for every subject. So in discourse, but many of the students are not actually familiar with discourse. I am familiar, so I saw this that today we have a class. Therefore, I just messaging my friend that we have a class.
Hmm.
Please join.
Hmm. Is there a WhatsApp group for this class or for your batch?
No, only discourse group is there.
Okay.
And
From this
earlier
sir,
it
all
was
these
space also.
communications have been held through discourse only. Officially, there is no communication through any other platform like GSpace earlier, which used to happen.
Actually, we have told our head of operations about that, but they did not want to go with every time GSpace and all in Discord. But actually, if I say that GSpace is very much clear communication between all the students and even the instructors and teachers. So we have suggested from our side, but I do not know about the course.
One more student is joined. Okay, Raj, where are you from? Ravanjan Kumar, where are you from?
Hi, sir. Good evening. I'm connecting from UK at the moment.
UK.
Yeah. So,
Raj, what about you,
yeah.
Raj?
Hmm?
Raj, where are you connecting from? What about Pratham? Saurdev Mukherjee, where are you coming from?
Sir, I'm from West Bengal, Kolkata.
Okay.
Good evening, sir.
Good evening, Raj.
Yeah, I am from Jharkhand, sir.
Jharkhand. Very good. Okay, we have also Saurav Sahu. Where are you from? Saurav Sahu.
Good evening, sir.
Where are you from?
Sir, I am from Odisha, sir.
Odisha. Okay. How many of you are working already in some company? Many of you may be already working. Huh? Sabanjan is saying, I think. Okay. All right. We'll wait for another 2 minutes. Aditya Kumar. Where are you from, Aditya Kumar?
Uh, so I am from Bihar.
Bihar. Okay.
So I just joined. So
Yeah.
yeah.
It's fine. Okay, while we are, waiting for others, maybe we'll start. Otherwise, it's time is short. So I'll just give you a brief introduction to this class, and then I will ask Ashutosh to talk about the grading and all that. Okay, so he will explain the various tests, etc., that you are going to have, and how the grading is going to be done and all that. So let me give you a background. So first of all, let me introduce myself. My name is Ravi Kumar. I was a professor at IIT Delhi many years ago, and then I was, I spent about 10 years there as a faculty. Then I moved into industry. I was working for Texas Instruments India for about 23 years. And now I am part of a startup company called Vinyana. So VLSI test or DFT is one of my interests. So let me sort of give you a background on testing itself. So I'm pretty sure you have all used instruments in your labs, various labs. I'm pretty sure you have used multimeters, you have used oscilloscopes, and many other instruments, right? So these are similar instruments are used for testing, characterization also, right? So that is the connection that you can make, right? But in this class, we will mostly focus on the design for testability. See, testing itself is a very big topic by itself, right? We will do some little bit of introduction to testing, but testing is more of a hardware oriented course, right? To teach a course on testing, one requires a tester, right? And testers are rather expensive, and access to testers is not easy. I just want everybody to be aware that there are such things called testers. They are very expensive. They may cost in millions of dollars. So where are they used, right? So I'm sure everybody has heard of integrated circuits, right? I'm sure you have heard about integrated circuits. See, modern integrated circuits are very complex, right? They may have, maybe hundreds of millions of transistors in them, right? So once upon a time, if you got an integrated circuit, it used to contain just a few logic gates, right? I'm sure they are still useful. Many of you may have worked with TTL integrated circuits, right? You may have used NAND gates, NOR gates, etc. So those are not too hard to test, right? So if you want to test an AND gate, let us say it is a 2-input NAND gate, and it is a digital circuit, so the only inputs are logic 0 and logic 1, right? So if you have 2-input NAND gate, you can only apply 4 possible combinations, right? 0, 0, 0, 1, 1, 0, and 1, 1. So you can exhaustively apply all the combinations and see whether the NAND gate is producing the required output. Otherwise, you can declare that it is a faulty gate, right? So that is how these electronic testers that you may have used in your college, that is how they work. They sort of exhaustively test, because the functionality of those chips is very simple, right? They are simple gates. At most, there may be some arithmetic logic unit or something like that, right? But the modern day integrated circuits are very complicated, right? They have a large number of gates, plus they also can contain other kinds of components like analog, mixed signal circuits, right? When I say analog, I can mean things like operational amplifiers. I can mean things like, maybe there are some power related components are there. Okay. Then there may be mixed signal components. For example, we may have what is called as a digital to analog converter or an analog to digital converter, right? So what is an analog to digital converter? It takes as input an analog signal and provides a digital output. Okay. So what is an analog signal? Where is it coming from? See, the analog signal may be the signal that a sensor will generate, right? So sensors are also sometimes included in the same chip. They are able to sense things like temperature or pressure or maybe some chemical content, right? So there are lots of different kinds of sensors nowadays. Tactile sensors, right? So these sensors, they convert the physical quantity into a small analog signal, which is very weak. So somebody has to amplify that signal. That is why we require analog circuits like op amps and so on. Then we may have to convert them into digital format, because our processing is usually done by a digital computer. So a long time ago, digital computers were not there. So people used to use analog computers. But today, invariably, we all use digital computers because they are more reliable. Right? In an analog computer, the noise can be a big problem. Okay? So in digital computers, they are more robust. They are not so sensitive to noise. So that is why we use digital computers. Right? So our integrated circuits have become very complicated. Right? They have a lot of gates. They have analog, mixed signal, digital, memories. So testing such an IC won't be easy, right? Earlier we talked about how an AND gates, etc., are tested. Those are easy, right? But I can't possibly test a huge microprocessor or something like that and try to exhaustively test it. It's impossible, right? Because a microprocessor can do so many things. We can't do what is called as functional testing. What is functional testing? Test whether it does the function that it is supposed to carry out. So in this class, we will start by telling what testing is, right? Why is it used? Testing is a way of ensuring quality, right? So there may be a company which makes lots of integrated circuits and sells them into the market. But before selling them, they should test them to see if they are good parts. Why will they not be good? Because they may have manufacturing defects in them. So any manufacturing process may have some imperfections, isn't it? When we manufacture an integrated circuit, a lot of things can go wrong during manufacturing. So we'll discuss that in the class also. But you can sort of try to imagine the processing of an integrated circuit. See, first of all, you have to start with a pure silicon wafer. But that silicon will have impurities. Similarly, the silicon wafer is supposed to be highly polished, but it may still have some imperfections. So any manufacturing process, okay, for example, at some stage we have to deposit metal uniformly on the entire surface, right? But the deposition may not be, we may not be able to make a uniform deposit. We may not, some parts may get missed out. Okay? So as a result, invariably there will be manufacturing defects in the integrated circuits, and knowingly we should not sell defective parts. Okay? So that is what quality is all about. So customers come to a company because they trust the company for quality parts. Okay? Which means that if I buy 100 pieces from a company, the chances are that all the 100 are good, or maybe there is the company will tell you that there is a chance that one of them may be bad or something like that. So if somebody can make an assurance like that, saying that there are no more than, if I sell you 1 million parts, and I can guarantee that not more than 100 will be bad, okay, then that person has made a quality statement. Okay, so that person is confident that his manufacturing is good enough, and his testing is good enough, because of which he can assure that there won't be more than 100 defective parts. There may be much less. Okay, in fact, there may be no defective parts at all. Okay. But they still have to make a statement about quality. What is the worst case scenario that they expect? And if we do find more defective parts, suppose the company is saying no more than 100, okay, defective parts per million, we also call it as DPM, defective parts per million. But suppose when we start using these parts, we realize that many of them are defective. Let us say 200, 300 are defective. Then we can go back to the company and say, you have broken your promise, and we can make them provide a compensation. Maybe they will have to provide additional components and so on. Okay. So testing is a way of ensuring quality. So before you sell the parts, you test. Just like in this class, all of you are going to learn something about testing and all that, right? Then we are going to test you. We are going to conduct quizzes, etc. And we'll give you a grade. Okay. In the same way, the parts that come out from the manufacturing line of a semiconductor company, they are also subjected to test. They're also graded. Okay. Sometimes the grade may just be go or no go, pass or fail. In your class, it won't be like that. We just don't declare only pass or fail. We have A, B, C, etc. So in the same way, the products may also be associated with grades. Okay, these are called bins. Okay. So the quality of an integrated circuit, especially let us say we are talking about an analog circuit or something like that, right? There may be some parts which are very good. They have very high, in operational amplifiers, you may have heard about things like gain, bandwidth. There may be other, offset. So depending on the, so if I take many ICs, each of them will have a different value. Similarly, in a digital circuit, I may have made a microprocessor which is supposed to work at 100 megahertz. But some may actually work at 150 megahertz. Some may work at 125 megahertz. Some may work at 100. Some may work, unfortunately, at 75 only. Now, if you try to increase beyond 75 megahertz, you will see that it doesn't work. Some failures are noticed. Okay. So we can also grade the circuits and say these are the speed bins. Okay. So the very high speed parts, they are sold for a higher profit. Whereas those which are not able to meet the speed requirements, either we have to throw them away or we can sell it at a lower price. Right? If they have bad defects, if there is a catastrophic defect because of which it fails at all frequencies, okay, then of course we have to throw it away. Okay? But there are certain defects which are what we call as parametric defects. They are not catastrophic defects. Okay? So what is a catastrophic defect? For example, if a wire is cut, okay, then you can't do much about it. In an integrated circuit, we can't repair it. So if a wire is short circuited to another wire, we can't do much about it. If a wire is cut, we can't do much about it. So we have to do all these things. First is to see whether it is functionally, whether it is a good or a bad circuit, whether it's a pass or a fail. Once it's a pass, we may also have to assign a grade. saying whether it is high quality, medium quality, etc., etc. So testing is expensive, right? Because we make lot of parts, right? We make millions of these parts, and to test one by one, as you can imagine, will be very time consuming, and it requires manpower. It requires a lot of machines or testers, which are expensive. A lot of it is now automated. Okay, so robots are used to pick and place those ICs and now operate the tester, etc. So this process is highly automated. But even then, it does take time. So test time is something that is a matter of concern for us. Similarly, the test cost. The cost is involved in terms of the high expensive testers that we have to install. Right, manpower is also very expensive. Then we have to maintain those testers. Right, they are we need maintenance. Right. So as a result, testers are. The testing is a fairly expensive thing to do, and in semiconductor companies, right, they employ a lot of people for design, and they also need a lot of people for test activity. So in the early days in India, when India started seeing the influx of semiconductor companies, in the early days, mostly design activity was done. So Texas Instruments was established in 1985, about 40 years ago. After that, a lot of other companies also came. Most of them set up their R&D centers here because they found good talent here, and they recruited designers to design integrated circuits or the software that goes into these ICs, etc. And the manufacturing continued to happen elsewhere. So manufacturing could happen in China, it could happen in Taiwan, it could happen in the US. And wherever there is manufacturing, that is where testers were located. Okay? It makes a little sense to keep the testers where the manufacturing is happening, right? So India didn't have too many test activities. But now in India also, we are seeing a lot of test activity. There are many reasons for this. Maybe the global picture is changing. Okay, a lot of political changes are happening in the world. There is a lot of tension between US, China, etc. So all these are resulting in a lot of changes, and in some sense, India has benefited from some of these things. And India is also beginning to, invest in manufacturing of ICs. In the past, India has not invested so much. Right now, you can see that you may have seen you may have seen reports, newspaper reports about jobs that will come up in the area of semiconductors. In Gujarat, fabs are being set up. And there are also, the fabs manufacture what are called as semiconductor dies, right? They are not yet packaged. Okay, so there is a separate activity called packaging. Okay, so assembly or packaging is another activity. So what is packaging? You have to take the die and you have to encapsulate it in a ceramic or a plastic which protects the die. Okay, the die is very small, right? It is too fragile, and you can't directly handle it. So you need either a ceramic or a plastic package, which also helps in dissipating the heat from the IC. So these packaging centers are also coming up, right? I've heard that these are all getting established. Some of you are from Orissa, Bhubaneswar, right? So there also they are talking about having these OSAT, right? And maybe others will also happen. Right now I have heard about Gujarat, Orissa, maybe there are a few others that will come up, right? But the point is, when all these things happen, we need people who are good at manufacturing, test, design. So we'll need all kinds of talent. It's not just going to be, design, right? India has focused only on that for a very long time, right? Now, unfortunately, I would say fortunately, we'll have to start looking for skills in the other areas. So this course is about testing, measurement, and more focusing on design for test. So it's like a one course. See, usually there is not more than one course that we can teach on the topic of testing and DFT, etc. Right? Ideally, there should be more than one course. There can be another course which focuses only on the test aspect, which is more like a lab, etc. But I don't think, not just in India, even in the world, I don't think we have too many universities which have such a thing. Because like I told you, these testers are too expensive for universities to purchase and invest, maintain, etc. The need is not there. Universities are not going to manufacture millions of chips and test them, right? They may even those universities which do have some little bit of manufacturing going on, they may just make a handful of ICs, and for that they don't need to use a expensive tester. What they will do instead is they will build a board, they will build a PCB, they will integrate that chip into that PCB, and then do a functional test. Okay, so that is an alternate way to do testing. So there is functional test and there is a manufacturing test. I hope you people understood the difference between the two. Though functional testing is a good thing, everybody likes to have functional tests, we just can't afford it. Okay, if I manufacture millions of microprocessors, imagine I had to have some sort of a small microprocessor kit, right? And I keep on inserting new ICs into that kit and keep checking if these programs run and all that, right? That's all very too much. We can't do all that. It's okay to do that when you have a very small number of ICs to test. But you can't do that when you are manufacturing in large numbers. So that is the reason why they have tried to design the chip itself for testability. So in this course, you will learn about various things like why defects occur, what are those defects, how they impact the circuit, what kind of faults occur in digital circuits, analog circuits, memories, right? And then how do we run tests for them, simple tests. Okay, we'll start with the digital testing, then we'll go into memory testing, and then towards the end we talk about analog testing. Okay, and finally system testing. So the breadth of the course is also rather high. So you will find that the videos are already recorded and they are made available to you. So you can read them, you can listen to them. I think we will also have these live sessions every week, once every week. So do attend these live sessions so that if you have questions that you could not resolve based on the videos, you are welcome to ask those questions here. So this is basically the brief introduction or motivation for this course. Okay. So it's a highly industry oriented course. Okay. So if you have done a course on electronic testing, measurement, then these are highly job oriented. You will find that there are jobs available in these areas and people want students who have this particular skill. Okay. So having said that, let me ask you guys if you have any doubts, and later I will ask Ashutosh to explain the quiz structure and all that stuff. Any questions before I ask Ashutosh to speak? What, Purba Shah, you have any questions?
No, sir.
Okay. What about Ayush?
Hello, sir. Good evening,
Yeah.
sir.
Yeah.
Sir, as you mentioned about the fabs which are being established in India, sir.
Mm.
Sir, they will be working on the latest technology as
Yes. If they have to be competent in the world, they cannot use older technologies, right?
yes,
So
sir.
absolutely, they will have to start using the latest technology, which means, see, for digital, I think a lot of ICs are still required in 45 nanometer, 65 nanometer, right? Many applications don't need beyond this. Okay? So not every IC needs to be 2 nanometer or something like that, right? So those are required when your application demands it. Like if you are making a very high-end microprocessor, you may require a 2 nanometer technology, right? FPGAs or high-end microprocessors. So those who will invest in these manufacturing lines, they will take a call based on the market to which they intend to supply. The manufacturing of very advanced node chips, the chips which are in 2 nanometer, 3 nanometer range, those are as you can imagine, the manufacturing is very complicated and very the equipment is also going to be very expensive. So it doesn't make sense to do those unless the market is already there. So those who are establishing these fab lines, they will, before they take that call, they would have made lot of they would have met a lot of people, understood, they would have created what is called as memorandums of understanding about that they will do business with them and so on. So they will use the technology that is most likely to succeed.
Yes, sir. Sir, various ATMP units are also being established,
Yeah.
sir. Yes, sir. So there they need some skilled laborers and skilled workforce, sir.
Yes.
Sir,
Right.
according to you, sir, what should we try or where should we try our best in order to be a good fit into the ATMP units, sir?
See, in ATMP also you require skills like in the test and measurement is a important aspect in there, in that also, right? There is also, you should be, see, what you should appreciate is manufacturing happens with machines, right? So there you can't really do too much, right? You have to, the value that engineers bring to the manufacturing is they have to be able to understand the terminology. So when the machine gives reports, right, at the end of every day reports will be generated, at the end of every week reports will be generated, lots of data is being collected, quality measurements are being made, right? So process control reports are being generated. So you need to understand these things, only then you will be able to sort of contribute to a job like that. So having knowledge of VLSI technology, having knowledge of what packaging technology is, what are the different types of packages, how are they tested, mechanical stress, thermal stress tests, mechanical stress tests. So you may have to perform all those things, right? So what I would advise you to do is they will also train you. So you don't have to think that I should know everything that they do before I join them. That doesn't happen like that. When you go for an interview in any of these companies, right, they are not looking for exactly whatever they are doing, that you should have that knowledge. That is impossible. They will give you some training, but in order to give the training, they expect you to have the background. Okay. If they are talking about packaging and you have no idea what packaging is, it's going to be difficult, right? If they use terminology that are commonly used in semiconductors, right, and you have never heard of those, diffusion you don't know, so then it becomes difficult, right? It becomes very slow. So you have to focus on your whatever topics IIT is giving you, right? Take those subjects seriously, understand, right? And that is what is going to help you. Like what IIT cannot do is offer a training to you to join that company. That is the job of the company which is recruiting you. Okay, the training that they give you is only for that particular job, whereas IIT is trying to give you the very basic foundation, which gets you ready for any of the jobs. You understand, no?
Yes, sir.
Yeah. All right. What others? Preetham, any questions? Pratham? What about Kaushal? Any questions?
Yes, sir. Good evening.
Yeah.
So I was also thinking about this. So how we can apply of all the opportunities which are coming in India. That since I am also from Odisha, I am also from Odisha. So how to know about that Fab Lab in Gujarat? It's like Tata Electronics is also implementing something. How to
Right.
apply that? Since we have also completed our diploma, we are in the degree level. After 2 years, we also complete our bachelor's. So how to enter in this testing measurement of semiconductor devices, ICs basically?
They will advertise, no? See, once they're ready to start recruiting, the advertisements will come out. See, they will advertise in newspapers. They may also advertise in campuses. So they will start that activity, sooner or later. Right now, I think they're in the process of setting up everything. Right, that setup takes time. Right. Meanwhile, they will start thinking about building the manpower required. Right. Initially, they would have recruited all the managers that are required. At that level, they would have already recruited. But when they need more people on the job floor, etc., they will advertise. So you just have to wait. Shivaraman, what about you? Rahul Raj, any questions? Okay, so let's ask Ashutosh to explain to us the various. Okay, Sauradev Mukherjee has a question. Yes, sir.
Sir, actually, I had one question, like not, I would say, directly related to our topic, but like I am interested in the robotics domain. So, like for the large and manufacturing, like QCA robots, so when they sell their products to B2B businesses, so sir, I wanted to ask that you were talking about the testing of the equipments, like they have a grading score upon which they are graded, and then it is sold to the customers as per the expectations. So, like, sir, if I talk about the models which are used in BMWs and Mercedes for car manufacturing, the QCA robot. So, what there, sir, if there is one defect in the product, I'm not talking about the software part because it can be altered via programming, but if there is any defect in the hardware part which has been, I would say, detected after the entire, I would say, manufacturing or the packaging of the product, then, sir, is that product rebuilt from the scratch again by breaking it down, or like it's just sent to Wayne, like that product is wasted? Like how these large and I would say high pricing robots are treated after they have a very serious defect, like of the circuits, or I would say of the IC logics.
Yeah. See, the way it works is, see, to build a robot, you need many things, right? You may need mechanical parts, you may need electronics. In electronics, you may require integrated circuits, you may require some other things like capacitors and resistors and inductors. So many things are required, right? So quality is applicable to each and every part that is purchased. So the person who is building a robot, that person wants to make sure that every part that is going into the robot has a very high quality. Now, if at the end of all this, see, testing is done not at the end. It's not like, first let us assemble the whole robot and then see whether it works or not. It doesn't work like that. They would have planned it in such a way that, there are subsystems in the robot. So they will get tested. And each subsystem may have further smaller subsystems. Finally, it comes to, individual parts, right? So it's very unlikely that at the end, when everything is assembled, the robot doesn't work. It doesn't happen that way. So the best way is you test individual parts thoroughly and then integrate it into the subsystem, test that subsystem. Then once that is working, put it into the next level system and things like that. So if you miss, see, the quality of the part, if it is not guaranteed at the earlier stages, see, suppose we miss the detection of a test in one of the components and that gets into the subsystem and there also somehow it escapes, the cost of testing will increase by a factor of 10. This is explained in one of the videos. It's called as the rule of 10. Okay. So if you miss detecting a fault or a defect at an early stage, okay, and then you allow it to go into a subsystem, then finding what the problem is at the subsystem level is 10 times more expensive. Then if you miss it there and it goes into a larger system, finally let us say it goes into the robot, right? And now the robot, see, you are fortunate if it gets detected in the before you sell the robot, right? Suppose there also you miss that particular defect, right? And you say supplied it to the customer, and at that customer's end, let us say something terrible happens, right? It has happened, right? These robots are used in shop floor, right, for manufacturing and so on. They're very. You may have seen some videos where these manufacturing robots are, so heavy things. They are moving all around. Somebody can lose their life. It has happened, right, because of the defect. So the answer to that question is that you have to keep testing at every stage. Okay, you cannot delay the testing till the end and say we'll test everything at the end. Okay? And so that you will understand that when you read about the rule of 10. Okay.
Okay, sir.
All right. I think we should now ask Ashutosh to explain the quiz. Ashutosh, please explain how many quizzes will be given. The
Okay, so we have planned two quizzes, quiz 1 and quiz 2. Both will be of both each will be of 25 marks, and then an end term for you. And if we felt like that we need, then there might be extra quiz, but I do that will totally depend upon our scenario. And in my live sessions or in professor's live session, there might be a surprise quiz for entire 1 week. There will be one surprise quiz that might be in this session or in next session. Okay, so this was his first session, so I did not took the liberty of taking the surprise quiz. So I wanted him to get familiar with all of you guys. So from next week, it might be a surprise quiz in my session or in his session. This is right now the plan. Yes, sir.
So you understood, right? Everybody has understood the way it works. The first quiz will be, when is it? March sometime, right?
Sir, 15th March.
So the first quiz will be on the 15th of March. And I think we already know what will be included in that particular quiz. The syllabus for that quiz is already known. I mean, in case you don't know what it is, you can always find out. Ashutosh will be able to tell you. Similarly, quiz 2. Quiz 2 will be based only on the material that is taught after quiz 1. Okay. So quiz 1 will include a certain number of lectures. Quiz 2 and quiz 1 are fully disjoint. There is no overlap in the syllabus for quiz 1 and quiz 2. But the final exam is expected to be all inclusive. Okay, it will expect you to know material from all the lectures. Yes, Prabhanjan Kumar, what is the question?
Is the quiz one pen and paper, or is it going to be objective?
Ashutosh, you want to answer?
So everything is going to be MCQ this time.
Yeah, because we have a large number of students, so it will be MCQ. But we want to make sure that all of you understand that the system they have designed for MCQ, etc., will show the questions to you in a random order, right? So don't think that everybody is getting the same order of questions, number one. And the order of the answer A, B, C, D also may change from one person to another. This is just to make sure that there is no malpractice of any kind. We expect everybody to study well and get the maximum out of the class, right? So don't engage in any kind of malpractice. Any other questions?